Hi everyone, let's solve this problem. Count good nodes in a binary tree. Given a binary tree root, a node x in the tree is named good if in the path from root to x there are no nodes with a value greater than x. So let's understand first path. So we all know this is the root. Path is nothing but a path between the root and any node. So path from 3 to 1 is a node, path from 3 1 3 is a path. So from 3 4 5 this is a path. So these are all the paths. So how do we define a good node? If let's say this is x and the path is 3 and 1, then the node value is less than the max value seen so far already. So in that case, this is not a good node. But if we traverse 313, this is also a path. If you see the value of this particular node 3 is equal to the max value we have seen, it is not violating the condition they have given here, right? Because of which it's a good node. So similarly, it is with 4 and 5. So let's understand it in more detail how we can solve this. So if we have this particular tree, now let's say I want to know the max value in the path seen so far. What can I do? I can calculate the max value and pass it to the children node, right? So if I pass max value here, it would be 3. Now again I will pass it forward. This would be again max value is still 3. Now it has reached null, the end of the left subtree. So now if it is null, how, like, what will be the good nodes? It will be 0. So let's say for example null returns 0. At this point of time, node dot value should be greater than or equal to max value for us to, it's a good node. So since this children left and right are null, it will return 0 and 0 respectively. So it should just add this particular result and send it. So in that case, what will be the answer to this? It will be 1. So result will be 1. After this, it will check here again. This condition is not satisfied. So it will return whatever was the previous answer. It will be 1 here, right? And at this node value, we already know that this particular is this value is already a good node because it's root. We will get to know it by default. So this is already 1. Now we will move forward again with max value to this particular node. In this case, max value is still 3. So we will further pass in the values, but we have seen a max value of 4 at this particular node. So we will be passing on the max value as 4 to its children. So now they reach null nodes, so they will be returning 0, and this particular node is not like validating this particular condition, so it will be not a good node. So it will be returning 0 from this particular edge. So it will be a 0, and again in this case it is a valid condition, so it will be returning 1 from here. Now we will combine all of them, 0 plus 1, and also this particular node, it will be 2. So it will be 1, whatever we have written so far is 1. It is 2 from here, it is 1 from here, 2 from here, and 1 here. So 1 plus 1 plus 2, it is 4. So now let's try to code this up. So let's say if we do not have a root node, that means we just have to return 0 good nodes. Otherwise, let's define a function to traverse the tree. While traversing the tree, we will pass a particular node and also we will pass the maximum value. So initially, when we are traversing, we will be passing the root, and also whatever is the tree, root value will be the maximum seen so far for its children on both the sides, right, for the initial iteration. So I will be passing root dot value. So now in this case, if the node we have passed is null, then we will be returning 0 because there will not be any result which we have seen or the good nodes. After that, now I will define the result and I will calculate if node dot value is greater than or equal to the max value I have seen so far. In that case, I will consider that as a good node, else it is not a good node. Now I also have to update my max value because there might be a case where the current node value can be a maximum than the previous one. If you observe this case where we have like 4, the max value was at 3 and the node value was 4. So if I have to pass the max value to its children, I have to update my max value. So I am updating it. Now I will traverse my left subtree. I will also traverse my right subtree. And whatever these subtrees written, I will add up to my result. Right? And then towards the end, I will just return the result. Now let's try to run this solution and submit it. It's accepted. So now let's try to understand the time and space complexity of this solution. Time complexity is big O of n if we are considering there are n nodes in a tree, because we have to at least traverse all the nodes at least once, so it is big O of n. And the space complexity is dependent on the height of the tree because we are using the recursion. So but in the worst case, if the tree is not balanced, it would be big O of n. And the result variable is just a constant space, so we can ignore that. So it's big O of n. I hope the solution is clear. Thank you.